All right, 7.4, quick lesson on lengths of curves. So finding the arc length. All right, so I said quick because I have 5 minutes left in the hour, less than 5 minutes. I'm going to try to get through this. So let's say I want to find out if this were a string and it was y equals sine x, and I graphed it from 0 to 2 pi. If I stretch that string out, how long would it be? We can figure that out using a formula that I'm about to show you. If you can imagine a whole series of right triangles here, if I added up the hypotenuse of all of those right triangles, and there are infinitely many of them, the sum of all of those hypotenuse would be the distance from 0 to 2 pi. Okay? So from here to here we could use the distance formula. The distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, so that's the distance between 2 points. So I'm going to call it just delta x squared plus delta y squared. Okay, so that is the distance formula. If I wanted to sum them, I could say, let's go from 1 to, I'll make infinite amount of them. So it's now delta x sub I squared plus delta y sub I squared. So if I add up all of those from 1 to infinity, I will have the distance of this smooth curve if I have an infinite amount of triangles there. So I'm just going to do some algebraic manipulation, and intuitively the first thing you want to do is divide by delta x sub I squared and multiply by delta x sub I squared. Everybody would have thought of that for sure. Yeah? Sorry, it's probably insulting to even show you that. So it's delta x sub I squared plus, well, I was just about rewrote the same thing. I'm going to pull out a delta x sub I squared from each term. There, nice recovery. So I'm going to pull that out. I'm left with 1 plus, now one of those has been pulled out. I have delta y sub I squared over delta x sub I squared, and we're summing them up. See what I did? I pulled a delta x sub I squared out of each of those. So I'm left with 1 plus this stuff. All right, so now I'm going to separate it. If I have the square root of delta x sub I squared, that's the same as delta x sub I. And now I still have 1 plus delta y sub I squared over delta x sub I squared. Now we don't like Riemann sums or summation notation. We prefer integrals at this point. Okay, so we could create this into an integral because there's an infinite amount of put that at the end. Delta y over delta x, well that's the same thing as dy over dx, and we're squaring them. And we're going from A to B. So if you want to find the arc length, all you need to do is integrate the square root of 1 plus the derivative squared from A to B, and you get your answer. So back to the one problem we had here. If I want to find this arc length, it would be the integral of the square root of 1 plus cosine x squared dx from 0 to 2 pi. You could plug that in the calculator, plug that in the calculator and that'll get you the answer. We don't know the antiderivative of that right now. Okay, so arc length is just the formula we derived right down here. All right, I did it in 4 minutes and 12 seconds.